We're going to start this lesson by trying to visualize an activity where we'll visualize potassium, and since it's a cation right here, it is positively charged, so it has lost an electron. So we show a little divot right there to show where it's lost something. And then we can show bromine right here, and we'll call it bromide. And it is an anion, so it has gained a negative charge, so that's why it's got the little point, it's got a little extra something. And so you find that the cation and the anion fit together perfectly to make this little rectangle shape, and that is showing us that we have a net charge of 0. Okay, and that is really the whole goal when you are trying to combine these two, an anion and a cation, is they're going to combine in however many numbers to make a net charge of 0. So we have one potassium and one bromine, so we would call this KBr, or potassium bromide. Now let's try another one. So let's see if we have oxygen right here as our anion, so that's our oxide. And so let's stick with potassium as our cation. Well, you'll see that you don't exactly make a net charge of 0 anymore. You don't have a full rectangle, so you'll need another potassium right here to make that full rectangle. So our formula for that would be K2O. Let's scoot that up so you guys can see it. K2O. See how that works? And that's saying that there were two potassiums, and you had two positive charges, two positive 1 charges, and then one negative 2 charge to cancel everything out. That's what that's saying. All right, so we had to have 2 potassiums for every 1 oxygen. Now, you can figure that out. It's not a coincidence that the subscript of the opposite one is the charge of this one. So you see how that's a 2, and then so that's the new subscript of potassium. This is a 1, that's the new subscript of oxygen. That is, but we don't draw the ones. So you have, let's try another one. So let's move on to type 2. If we have copper, the oxidation number is copper is 2. So that's that Roman numeral 2, which means that it's a 2+ charge. So that means that we'll take our bromine again, and we need 1 bromine here, and then we'll take another bromine to make copper 2 bromide. And that's the way we would say that, copper 2 bromide. And the formula would be CuBr2, copper 2 bromide. And then we'll, this is mostly just review for you guys, but let's check out this guy. If we have lead, and then if we have nitrogen, we were definitely going to run into some problems because lead is a 4 and nitrogen's a 3. So if you can see in the future, we are going to need an extra lead here. I'm sorry, an extra nitrogen, and then another nitrogen, and so right now we're up to 2 leads and 3 nitrogens. And I have to add another lead and then another nitrogen. So we ended up making quite a lot, and we ended up making Pb3 and 4. That's because it took us 3 leads and 4 nitrogens to make a full actual rectangle. That is enough to cancel out all the net charges. So you see that the charge of lead was 4, so the subscript of the other one, nitrogen, is going to be 4, and then the charge of nitrogen was a 3, and so the subscript of the other one is a 3. So that is the crisscross method. Hopefully that is helping you visualize it at least. Okay. Now the crisscross method does fail you in one retrospect, and that is for something like copper oxide. Okay, because this is going to be Cu2+, and this is going to be O. Okay, you see you only need 1 copper and 1 oxygen to make CuO. So this would be copper 2 oxide. All right. Now normally if you were doing the crisscross method and you had the 2 and you placed it as a 2 down here and then a 2 and you place it as a 2 down here, if you switch those charges you would end up with Cu2O2, and that is not correct. That is not the least formula unit, so we would not write that. We would write CuO. That would be copper 2 oxide. So now let's really get into the meat of the lesson, and let's talk about our polyatomic ions. So a polyatomic ion is something like this. This is a nitrate. It has it is an ion, and it has more than one atom. So that's why we call it polyatomic. So we're going to treat them as an entire group. You'll see that it's got its own little piece right there. So NO3 is its whole group. This would be potassium nitrate. So you'll see that nitrate is different from nitride, all right, and it's different from nitrite. Nitrate is specifically NO3, and it will always be NO3, and it will always be a -1 charge. So this group right here, this nitrate, is this nitrogen and the oxygens are covalently bonded together, but when they do that, they actually have an extra electron, so that's why they are an ion. They actually end up having more than one electron than they're supposed to. So they are going to attract a cation to them, and so we get this type of thing called potassium nitrate. So the way we would write that is we would write it as KNO3. Okay, potassium nitrate, KNO3. Now there's only one nitrate, so that's fine. Now let's take a look at another one. You could take a look at potassium hydroxide. Now this is a very common one in chemistry because this is a base. It's the opposite of an acid. And so like you might expect, we would call that potassium hydroxide, KOH. Very simple. So OH is always hydroxide, and hydroxide is always a -1 charge. Now let's try another one. Most polyatomic ions are going to be negative, and except for one. One of them is going to be positive, and that is going to be ammonium. Okay, so you can have ammonium. It is the +1 charge, which means when they are all bonded together, it is actually missing an electron, and so this would be ammonium hydroxide. So we would draw that. We would write that formula as NH4OH. All right, we'll do a formal lesson on this in a minute. And then let's take a look at something like iron. We have iron 3+, that's a transition metal, so it is a type 2. And so the oxidation number is 3, the charge is +3. So if we had hydroxide, again, let's say we have hydroxide here, well then there's another hydroxide, and then we have to have 3 hydroxides to make a net charge of 0. So we would write it as, it's getting a little squirrely on me. We would have to write it as Fe, iron, and then we would have to say that it was OH, parentheses, in parentheses, and then that's a 3. You may not write it as FeOH3 because there's a problem with that. That's indicating that there's only one oxygen and 3 hydrogens. That's what that's saying. So you have to put parentheses around the group. Remember, you're thinking of this thing as a group. It's one piece right here. So you've got to think of this as OH, and there's 3 hydroxides. So that's why we put parentheses around it. Make sure you don't forget that. So let's try one more. If we had aluminum, we could add another thing like phosphate. And so we would call that guy AlPO4. We don't need parentheses around it because there's only one phosphate. So we would just write AlPO4, aluminum phosphate. Probably the nicest thing about polyatomic compounds is that you do not need to know. You don't have to memorize them. Yay you. You just need to know that they're treated as a group. So we'll look at nitrate again because that's a real popular one. And so nitrate has this cool little structure where they're all covalently bonded like this. I'm not going to show, there's actually lone pairs around there, but it is a whole group of that. And if you count up all the electrons that it's supposed to have versus how many it actually does have, it has one extra negative charge. So that's why it's a -1 charge, and it's a whole group. And that ion will attract other cations. So you'll see that the only positive one on this list is ammonium, and that is actually not here. So we have ammonium, ammonium, and that's NH4. It's a positive charge. I'll go ahead and give you on this periodic table. If you flip over to the back of the periodic tables in the classroom, you have all these polyatomic ions here. I'll post this in Schoology so that you guys can see that. So those are always for your reference and very easy to find. So very cool. You may want to check that out where you are in the video. So let's start naming them. So we have Na, and then we have C2H3O2. So that's not sodium, carbon, hydrogen, oxygen. That is sodium. And then we see this group of atoms right here, and then this is C2. This group right there is acetate, right there. And so we'll call it sodium acetate. We're not going to change the ending. We're not going to do anything like that. We're just going to write down the name of the polyatomic. So now this guy is copper, and this is NO3, and NO3 is nitrate. So remember that copper is that pesky type 2. So we have to do a little bit of deductive reasoning here. We know that nitrate was a -1 charge. There were two of them. So 2 times a -2 charge is going to be a +2 charge. So that is going to be copper 2 nitrate. This one's a little nicer. This is type 1. This is potassium. And that is KClO3. So that's going to be potassium chlorite. Because all you did was take a look at oh, that's not even on the list either. That's annoying. Potassium chlorate is right there. ClO3 right there. So let's add chlorate. ClO3 minus. Hopefully we get them all. So here is NH4. So that's ammonium, and then there's SO4. That's sulfate. So we're going to call this ammonium sulfate. You'll find these polyatomic compounds are very frequent. So here is Mg, and then here's C2O4. And so that is, C2O4 is an oxalate. So we'll call this magnesium oxalate. Oxalate. And then here's lead, and then here is CO3, which is carbonate. And so carbonate is right there, CO3, and that's a 2- charge. So CO3 is a 2- charge. There are two 2- charges, so that's a total charge of -4. So that means that this guy has to be a total charge of +4. So that's going to be lead 4 carbonate. Let's try the bottom part. Here's sodium cyanide. Ooh. So sodium is +1, and then cyanide, that is Cn, and that's a minus charge. Okay, that's this guy. So sodium cyanide is NaCN. The positive one and the negative one cancel out. We'll just call it NaCN. So iron 3+, iron 3 plus. And then nitrite. Nitrite is NO2 minus. So that is going to make it, the 3 is going to come back over here to this side. And so we'll need 3 nitrites. So we're going to draw parentheses and draw a 3 right there. Do not do this. Don't do NO2 and then put a 3. Because now you just said that there's 23 oxygens. See how there's a problem with that? That's why we got to put parentheses around it. Okay? And then so there's nickel 2 acetate. So that's nickel with a 2 plus charge because the oxidation number is 2. Acetate is C2H3O2 with a minus charge. So that 2 comes down to the other side. So we're going to call it nickel C2H3O2, and there's a 2. And then barium phosphate. Barium is a 2 plus charge. Phosphate, you can look it up. It should be on the top. Yeah, phosphate is up there on the top. So that's a 3 minus charge. And so the numbers will switch. So it's going to be barium with a 3 down the bottom. And then phosphate is PO4 with a 2. Ammonium is NH4 with a positive charge. Talked about that. And then chlorite. Oh, chlorite is not on your list either. That is slightly annoying, isn't it? So chlorite is right there on the white chart. Yellow. Well, it's not white. It's yellow. Dummy. ClO2 with a minus charge. ClO2 with a minus charge. So that is NH4 with ClO2 with a minus. Yeah, ClO2. And then we have lithium, and then carbonate, CO3, the 2 minus charge. So that means that it will be, that 2 will come over to the lithium, and then the 1, we just need 1 carbonate. So we need 2 lithiums for every 1 carbonate. So Li2, CO3. All right, I hope you enjoyed polyatomic compounds. That is going to wrap up the last lesson of the unit, and we're done. So have a great day.